Right, weekly paper number 20. The first question, two balls A, B of masses 4m, m respectively are placed on a smooth horizontal table. Right, 4m, m, AB. And the ball A is given speed u, right, such that it collides with B. If the coefficient of restitution between the balls is C, show that the speed of A after collision is this much. Okay, so this is just before the collision. We'll mark the velocities just after the collision. OM, M, V1, V2. Asking to find, right, V1, no? Right. So we can apply conservation of linear momentum after the impact. Total momentum should be equal to before impact total momentum. After impact total momentum for mv1 plus mv2. Before impact it's for mu. M, M, M. You can cancel down. For v1 plus v2 equals 4u. Second, you can apply Newton's law of restitution this way. Okay, it is what? E times velocity of approach u equals velocity of separate v2 minus v1. Number 2. Asking v1, we can take 1 minus 2. Asking v1, then we get v2 and v2 we can cancel down. For v1 minus v1 is by v1. Here for u minus eu, take u out. For minus c, v1 is u upon 5. For minus c, this, right? If the speed of b after collision is twice, I will find v2 also. v2 we can find like this. V2 really we can find we are given for the speed of the b, right? For the speed of b after the collision is twice that of a, so that e equals to that, right? So v2 equals 2 times v1. No? That's what we are given. Speed of b, v2 after collision is twice that of a. v2 is 2v1, correct. Now what we do is, right, we put that in number 2. Okay, number 2 or number 1, wherever we put, we get the answer. Right, substitute for this v2 to v1 now by 2. v2 is 2v1 minus v1 is equal to eu. Here v1 equals eu. v1 answer u by 5. 4 minus c equals eu. This and this you can cancel down. 4 minus c is equal to 5e. Take this right hand side. 6e divided by 2. We get e equals 2 by 3. 2/3. Second question, number 2. We say we are given This angle given as alpha, this angle given as beta. Here the weight uniform means weight acts through the geometric center of the sphere. Here the normal reaction passes through the center, and here also normal reaction available, that also passing through the center. If the pressure on the plane of inclination alpha is half of the weight r, this is the pressure. This pressure means here force, right? Half of the weight of the sphere, prove that this r. Let us take this as r. Okay. Now we can consider the equilibrium. Right. You know, when this angle is beta, by ordinate angle this is beta, therefore this is 90 minus beta. When this is alpha, this is 90 minus alpha. Okay, right. So then here when we construct vertical line, since this is 90 minus beta, this should be beta. Here when we construct vertical line, this is 90 minus alpha, this is therefore alpha. Okay. Now I can write the equations for the equilibrium of the sphere, right? When I write the equations for the equilibrium of the sphere, we can write this way the equations. We can resolve horizontally, we can resolve vertically. When we resolve horizontally for the equilibrium, here we get this was W by 2 cos 90 minus alpha, W by 2 cos 90 minus alpha is sin alpha, R cos 90 minus beta, cos 90 minus beta is sin beta, R sin beta is equal to W by 2 cos 90 minus alpha is sin alpha, thereby we can subject R W by 2 sin alpha over sin beta. Right, first one. Okay. So now we can resolve the forces vertically upwards, right? Resolving upwards this way. Right? There we get this angle is beta, no? R cos beta. Here W by 2 cos alpha. R cos beta. R cos beta plus W by 2 cos alpha equals W, no? Right. Substitute for this R, that answer here, W by 2 sin alpha over sin beta is the value of R into cos beta here. W by 2 cos alpha equals W. W you can cancel down. Asking to find the answer for tan beta, right? Here we have cos beta by sin beta is cot beta, right? Here we have sin alpha by 2. Here cos alpha by 2. Here 1, right? We'll multiply this by 2. Okay. Then sin alpha cot beta cos alpha is equal to 2. Take this side, divide by sin alpha. Cot beta 2 minus cos alpha divided by sin alpha. Cot means 1 over tan, no? Then 1 over tan beta is this. Take the reciprocal both sides, then tan beta comes to numerator, left hand side. Answer coming sin alpha over this. Therefore, tan beta is equal to sine alpha upon 2 minus cos alpha. That answer coming now. Right. Next question number 3. Okay, no? Right, number 3, given this way. In the usual notation, I plus 4j, lambda I plus mu j, and I plus 5j be the position vectors of 3 points A, B, and C respectively with respect to a fixed origin O, where lambda and mu are positive constants. The diagonals of the quadrilateral OA, B, C are equally in length and perpendicular to each other. Write down AC vector scalar product so that lambda equals 4, mu equals 3. Right. Now, here this way we have x-axis into vector is I along that, y-axis into vector is j along that. This way we have here A coordinates for 1 because A has the position vector for y plus j, right? That means OA vector. OA vector OY plus j, right? Then B lambda I plus mu j. Here B coordinate should be lambda comma mu. The OB vector only given as lambda I plus mu j. We are given both lambda mu positive. Therefore, that point should be in the first quadrant. C has the coordinates 1, 5 because of C I plus 5 j. Okay. What's asking there? Diagonal of the quadrilateral or ABC are equal in length. This OB length and AC length equal. Right. Write down AC in terms of I and J, AC vector. Right. How to write AC vector? You know AC vector, you can write position vector of C, second letter in the left hand side, minus position vector of A. Right. AC vector, position vector of C means of C 1 plus 5j. That means I plus 5j. Right. Minus position vector of A for y plus j. Okay. Then AC vector I minus 4, I minus 4i means minus 3i plus, all right, 4j. Right. And next one, using scalar product, show that lambda 4 mu 3. Okay. Now we can write another data given us, the diagonals of the quadrilateral OABC equal in length and perpendicular to each other. These two are perpendicular. Right. Equal and perpendicular, right? Equal and perpendicular mean, you know, AC length mean AC vector modulus. How to write? Minus 3 perfect squared plus 4 squared root. Right? AC length means vector AC modulus. How to find the modulus of a vector? I coefficient square plus j coefficient square root. Then AC length going to be, this is 5. Right. OB length means OB length mean OB vector modulus. Therefore, OB length I can write square root of OB vector modulus. OB vector is this, no? Its modulus you can write lambda square plus mu square root. I coefficient square plus j coefficient square root. Lambda square plus mu square root. But OB and AC are equal since OB equals AC. We can write what? Square root of this is equal to AC. AC is 5. Okay. Then we can take one equation, square in both sides, 25, number 1. Right. Now, AC vector perpendicular to OB vector. Therefore, we can write AC dot OB should be equal to 0. You know, when two vectors are perpendicular to each other, dot product of the vectors being 0. Right. Now, AC I can write here minus 3i plus 4j dot OB is this lambda I plus mu j should be equal to 0. Right. You know how to take the dot product between two vectors involving I and j. We have to multiply I coefficients here minus 3 lambda, we have to multiply j coefficients plus 4 mu should be equal to 0. By this you can write 4 mu equals 3 lambda, mu equals 3 lambda by 4. Right. Now we need to find lambda and mu, no? Right. Now this mu 3 lambda by 4 we substitute here in number 1 and keep simplifying, we can do this. Right. By 1 we can write lambda squared. Mu squared means 9 lambda squared by 16. 9 lambda squared by 16 is equal to 25, right? Multiplied by 16, right? So then we get 16 lambda squared, 9 lambda squared equals 25 into 16. Here we get 25 lambda squared, 25 into 16, 25 can cancel down. Lambda equals 4. Reason plus or minus don't put because lambda given as positive, therefore directly positive answer you can take lambda 4. If lambda 4, putting here lambda 4, we get mu 3. Right? Therefore mu is 3. This is how we take that answer. Right. Next one, joint rod question number 4. Right. Right, there we are given this basic question. ABCD is a framework formed with 4 equal uniform rods, each of weight W. The framework is suspended from A, and the rhombic form is maintained by a light rod joined into the midpoints of BC and CD. If ABC angle is 2 theta, show that the thrust of the light rod is for W cot theta. Right. You see, we get then Right. T dash, here the midpoint. Right. Okay. Now here A, B, C, D. Weight here W, weight here W. Same line when you join here. Midpoint available here. W. Right. The tension, the thrust, really the BC rod and CD rod trying to come closer to each other. It is prevented by the light rod giving two forces away. Then the forces acting in the rod should be T, that is the thrust. When this is how we mark a thrust. Right. So then here I take the system is symmetric, right, about the AC line, and the joint C lies on the symmetrical axis. So therefore, at the joint C, the reaction is horizontal. Right. Then you can write the first thing is, since the system is symmetric, the reaction at C is horizontal, right? You get 5 marks for this. And we are given ABC is theta. ABC is 2 theta. This angle 2 theta. But you know, this is a rhombus. By a rhombus, by the diagonal of a rhombus, the angle at the center, angle at the vertex bisected. Huh? This whole angle 2 theta, no, therefore this is theta, this is theta. And also, the diagonal bisect each other at right angles of a rhombus, here 90. This is also theta, opposite angles, right, of any parallelogram equal. Parallelogram is this parallelogram, no? Right. So therefore, I'll assume the rod has length 2a. Then I take this way. First, for the equilibrium of rod BC, I take moment around A. Secondly, for the A, B, C whole part, we take moment around A. Okay, right. Then for the BC part, for BC, we take moment around B anticlockwise. You know, when you take moment around B, right, this excuse, when you push this way, rod BC rotate wheel anticlockwise. By W, rotate clockwise. By T, when you push this way, BC rod around B clock, rotate clockwise. Okay, then only one anticlockwise moment is made by X. Then moment of X is what? Moment means force multiplied by the perpendicular distance, right? The perpendicular distance to this line of action of X going to be, when you drop a perpendicular from B, right? This is required length. If this is theta, this is also theta. From here to here, 2a. This is theta. Then opposite side is 2a sine theta. X into 2a sine theta. Right. Other moments are negative. Then either we can put negative on the left hand side, or put in equal sign on the right, we can write them as positive moments. Right. So then W into, right, from here to here the distance is, from here to here A, this is theta, A cos theta. W into A cos theta plus T into, this is the line of action of T. When you produce this way, to the line of action of T, the distance from here to here. If this is theta, this is also theta, then the opposite side is going to be A sine theta, T into A sine theta. A, we can cancel down. Then we can divide this by sine theta. Then here we get 2x. When you divide this by sine theta, we get T only. Bring this T to this side, minus T. When this is divided by sine theta, cos by sine is cot W, cot theta number 1, right? Now we'll take for the part A, B, C, moment around A. ABC part, we take moment around A. For A, B, C part, we take moment around A. We take moment around A. Okay. So once you take moment around A, you have to assume this way: A, B, C, right? That ABC part can only rotate around. That's the thing. You know, here we have a free joint at B, right? Around B also, these two rods can freely rotate. But whenever you take moment around A for this ABC, so we assume for a while this around B the two rods can't be rotated, right? So then this ABC is a rigid one. That means around B the two rods cannot rotate. So then when we have something like that, when we apply this way W force here, the two rods A, B, C will rotate anticlockwise, right? So it's W, right, around A anticlockwise. This T, then clockwise, right? This X, right, anticlockwise. So therefore, around A, when you take moment, right, this W and this W and this X, all three will give anticlockwise moment, whereas this T gives clockwise moment, right? Okay, then we can write anticlockwise moment only we suppose take W, right? You know, by geometry, due to symmetry, this W line and this W line, they lie on the same line, right? So therefore, at once we can take the moment by this W and W, right? W and W, 2W, right? Here, if this is theta, this is also theta. From here to here A, then this length is A cos theta. Then 2W A cos theta. 2W A cos theta is the moment of the both W weights. By this X, again anticlockwise moment, plus X into, right? To the X from A, the perpendicular height going to be from here. Right, what do you get there? Here 2A, here theta, so this is 2A sin theta. Here 2A, this is theta, this is 2A sin theta. 2A sin theta, 2A sin theta is 4A sin theta. 4A sin theta should be equal to T times, right? This is the line of action of T. The distance we need from here to here. This 2A sin theta. This part is equal to this, that is A sin theta, then 3A sin theta. A you can cancel down, no? Right. Then again divide by sin theta. Then we get 2W cot theta here, 4x here, 3t there. Okay. Then take this right hand side. Then 3t minus 4x is equal to 2W cot theta, no? 3t minus 4x equals 2W cot theta. This is number 2. Right. By solving these two, we can find this what? T, no? Asking the T. Thrust of the light rod. Okay. Now you can do that this way. First equation, we multiply by 2. Then here we get 4x minus 2t, no? That resulting equation we add with this number 2. Then here when we have 4x, when you add that to with this minus 4x, the x term will cancel off, right? So therefore, we can do it like this now. First equation we multiply by 2 and the resulting one we add with this number 2, right? So therefore, here we get first equation multiplied by 2 means 4x, right? And this minus 4x will be cancelling. Here minus 2t plus 3t, then t. Right hand side of number 1 we multiply by 2, 2w cot theta, here 2w cot theta, or w cot theta. That is how we get that answer, right? Right, question number 5. next one. Right. Two trains XY move into same direction, right? On straight parallel tracks, pass the station A simultaneously, like this. Here the station A of the trains. Right. This is train X. This is train Y. So same direction on a straight parallel tracks pass the station A simultaneously with velocities 2u, 3u. This is with 2u and this is 3u. Acceleration 3f, 2f. This is 3f. This is 2f. Right. After time t at the point B, the train X overtakes the train Y. Point B is here. Train X. Y. Distances traveled by them should be equal during the time t1, right? So this is the time t1, here time 0. Show that this answer. Find the velocities of the trains X and Y at this moment. Afterward, the train Y maintain a uniform velocity. This maintain a uniform velocity, right? And X moves with uniform retardation. After this, X moves with uniform retardation if, right? After another time moment at a point C, the train Y overtakes the train X. Suppose somewhere here, train Y overtakes the train X, while the train X moving with retardation. So therefore, between B and C also, the distances traveled by the two trains being equal. Okay, right? Ask and draw the velocity time graph. Right. So then we can draw the VT graph like this. This way I draw it. Okay. Right. Train X. Velocity time. To U, 3U. Right. Right. This way. Right. This angle is alpha. Then tan alpha is the acceleration of train A. It is 3f. Okay. Train B, train Y. This is train X. This way. Suppose this angle is beta. Tan beta gives the acceleration of y. Tan beta y is 2f. Right. Now, this is the time moment t1 because when x overtakes y, from the beginning, the distances traveled by them should be equal. So therefore, this is the time interval. This time is t1. Oh, right. Then we can find the velocities here. This velocity is v, right? I'll take v, this as w, right? This angle is beta. The areas should be equal, no? Thereafter what happens? The train X, this is the train X, right? This is the train Y, right? Train Y continues the journey with uniform velocity like this. Uniform velocity like this. Train X begins the retardation like this. Then again, when this y overtakes, this happens between B, C, no? This happens at C. Then between B and C, the displacement traveled by them again should be equal. Okay? Therefore, I can mark this way. This area, blue area and the black area should be equal at the moment this y overtakes x. Right? Right. Then this angle, if I take, this angle should be gamma. Right, tan gamma should be the retardation f. Right? Okay. First one now asking to show that T1 to U of f. Right. So you know, if I take this as A, B, C, this point as D, E. Then this OA BC area, right? OA BC area, OA BC area is equal to ODEC area. ODEC area, right? This we can use, right? Now this velocity V, you can write how? You can write it like this. You know, the equation of motion we have, V equals U plus AT, no? Right. Think this, U means initial velocity, 3U. Acceleration of that Y, 2F. Time is T1. Then the velocity here, we can write what? V equals, right, 3U plus acceleration 2F time T1. Likewise, W you can write. W you can write. Initial velocity 2U, right? Acceleration is 3F and T1, right? These two areas equal. These two areas are what? trapeziums. Then you can put them there. OABC area half OABC, but 2u plus W half sum of the parallel sides, 2u plus W into 2e1. Right. ODEC half ODEC 3u plus V sum of the parallel sides into T1. Half T1, half T1 you can cancel down. Okay, here 2u W 2u plus 3f T1 3u plus V 3u plus 2f T1. Okay, bring to this side. 3f T1 minus 2f T1 is ft1. Here 6u, here 4u, it's 2u. When you take this to the side, T1, then we get 2u by f. All right. First answer is coming. This is now 2u by f. Right. Right. So then here, next area. I'll take this is f g h. Right. Secondly, this area CEFG area is equal to CBHG area. Okay. Then here the velocity we know W we found this one. That W velocity you can find substitute for this T1. The answer is right. Okay. Then W we can write W going to be 3u plus 2f times T1 to u over f. This and this you can cancel down. Here 4u, here 2u. It is right. Coming as 6u, no? It is 6u. Right. Now 3f T1 2u, sorry, here I made a mistake, no? W, here we have 3f or 2f. Then here we have 8u. Right. Also the same way we can find V. V is equal to 3u plus 2f T1 2u over f. This and this you can cancel down. Here we have 4u and 3u. V is 7u. Correct, no? 7u coming. Okay. Then here this W is 8u. V is 7u. Right. Okay. Up to there, it's correct. Now we know between B and C, the traveled by the trains X and Y are also equal. Therefore, now I am going to equate between B and C, the displacement traveled by X going to be CBHG area. It gives CEFG gives the displacement traveled by train Y. Okay, right. Now, I'll take this right. Now, I'm going to find this velocity given by this height. Right. That means when y overtakes x, the velocity of x. Right. You can find it like this. Here we have a retardation for the train x. Then we can apply v equals u plus at. Initial velocity 8u. Here retardation minus f. T. I am going to assume this time as t. Then t. Here. Okay. Then we get this velocity. What is that? 8u minus ft. Right. Now, certainly you can equate CBHG. CBHG area is equal to CEFG area. CEFG area. Right. CBHG is a trapezium. It is half sum of the parallel sides. First height is 8u. Right. This height is 8u minus ft. Perpendicular height is capital T is equal to CEFG. CEFG 7u into T. Right. T and T you can cancel down. Here this 2 we can bring here. 14u. Here 16u minus ft. Okay. Then we get T. Take this to the side. This to this side. 2u divided by f. Therefore, this time also the same 2u over f. Okay. Now asking to find the velocities of x and y when y overtakes x. When y overtakes x, y has a velocity still 7u, right? And x has the velocity, we'll calculate. Velocity of x. Velocity of x, if I take as Vx, okay, when y overtakes x at the point C, this happens. When y overtakes x, the velocity of x I took as Vx, it is given by this. 8u minus f times t 2u over f. This and this you can cancel down. That occasion, the velocity of x is 6u. That occasion, the velocity of y is 7u because it is moving after b with the constant velocity, right? Vy that occasion, velocity of y that occasion is 7u. Right. Now asking the distance between A and C. Distance between A and C means one area. Either area below the blue one or black one, whichever you take, correct. Okay. Then we'll find one area there, that is the distance between A and C. Okay. Now we'll find that area. I'll take this ODEFG area. O, right? D, E, F, G area. O, D, E, F, G area. That is the total distance traveled. First, I am going to find this O, D, E, C area. It is a trapezium. What is that? Half sum of the parallel sides. This is 3u. This side 3u, and this side 7u. Into perpendicular distance 2u by f plus this part is a rectangle 7u into this 2u over f. 7u into 2u over f. Right. So then I can take that 2u over f you can take out. Right. Then here we have 7u, 3u, 10u divided by 2, 5u. Here 7u. Here 14, you know. 12. 24. 5, 7, 12, 24 u and u squared over f. I don't know. 12u 2, 24u squared over f coming as the distance between the points A and C. Okay. This way we can take that answer too.